Hello, today I am going to start paper 2 AIHL November 2024. So let's start with question 1. A survey was answered by 20,000 expatriates, people living in a country that is not their own. The data ranked countries in order of the country they felt was best for expatriates. The highest ranked country was Switzerland. These results were compared to happiness score taken from the World Happiness Report 2022. The following table shows this data for the top 10 expatriate countries. So first row is for countries: Switzerland, New Zealand, Spain, Austria, Australia, Cyprus, Portugal, Ireland, UAE, France, Netherlands. Second row is expatriate country rank from 1 to 10, and third for their happiness score. Now in A they are asking for the happiness score find the upper quartile, and second the interquartile range. So for the upper quartile, that is the median, the mid value of the upper half of the data. So first step is to arrange the data in increasing order. So that is happiness score here. So I will write the happiness score in increasing order. That starts from 6.0, then next is 6.2, next is 6.5, then 6.6, 6.7, then we have 7.0, 7.2, 7.2, 7.4 and 7.5. As there are 10 data values in total, so you will just divide 5 in one half and 5 in other half. So in order to find the upper quartile, we will see the median, the mid value of the upper half of the data, and you will see here that is 7.2, and we name upper quartile as Q3. Then second, interquartile range that I will write as IQR, that is Q3 minus Q2, where Q2 is the lower quartile, Q3 minus Q1, sorry, where Q1 is the lower quartile. So your lower quartile will be the median of the lower half of the data, that is 6.5 here. So IQR will be 7.2 minus 6.5, that is 0.7. Okay. Next, for part B, they are asking show that Switzerland's happiness score is not an outlier for this data. So if you will see the happiness score of Switzerland, that is 7.5, that is the highest value of the data. So we just need to find the upper boundary and check whether the value 7.5 less than that or greater. If it is less than that, then it will not be an outlier. So how we find the upper boundary? We have a formula for that. So upper boundary is equal to Q3 plus 1.5 times IQR. So we know Q3, that is 7.2, plus 1.5 times IQR, that is 0.7. And if you will calculate this, the value will be 8.25. And if you see 8.25, that is greater than 7.5. So if it is greater, that shows that Switzerland's happiness score is not an outlier for this data. Okay, this is the reasoning for that. Fine. Okay, let's see the next part of the question. So the happiness scores were ranked to calculate Spearman's rank correlation coefficient RS. These ranks are shown in the following table. So again we have a table where row 1 is for country, row 2 is for happiness score, row 3 for happiness rank. So C part is write down the values of A, B, C. So they have not ranked New Zealand, Spain and Australia, and they are asking us to rank these countries. So rank will be according to the happiness score. Highest is the score, higher will be the rank. So I am just writing score and rank. Okay, so first one is 7.5, rank will be 1 for Switzerland, then 7.4 for Netherlands, rank will be 2. Now after this, lower values are 7.2, 7.2 for New Zealand and Australia. So let me write the name so that you are not confused. 7.2, and for Australia also 7.2. So now these are on third and fourth position. We need to decide the rank for them. So in case when values are same, what we do, we just take the average of the rank. So it should be 3 plus 4 upon 2, that is 7 upon 2, and that is equal to 3.5. Okay, so that's how we will decide the rank. So rank for both will be 3.5 and 3.5 because they have the same score. Next, if you will see the value after that, that will be 7.5 and they have 7.0 and rank will be 5 that they have already mentioned. Then we have next 6.7 and rank is 6. Then next we have 6.6, rank is 7, and then after that we have 6.5 for Spain. So we have Spain 6.5, only one value is there, so its rank will be 8. And next we have 6.2, rank 9, and 6, rank 10. So from the table you can see the value of ABC. A is for New Zealand and that is 3.5. B is for Spain, that is 8, and C is for Australia, that is again 3.5. Okay, so that's how you will decide the rank. Now the first part, they are asking us to find the value of RS, where RS is Spearman's rank correlation coefficient. So for this you just need to plug in the data values in the calculator. There is an option to find the coefficient. You will plug in the happiness score, happiness rank over there, and it will automatically give you the value for RS. So you will see, you can check, it will be 0.164. I have approximated it up to 3 significant figure, and in bracket I am writing the value that I got in calculator. Somewhat this value was there. So if you will approximate it up to 3 significant figure, it's 0.164. Then second part we have, if France happiness score is upgraded to 6.9, explain why the RS does not change. So earlier France score is 6.7. So they are saying if we upgrade it to 6.9, so let's see whether there is a change in rank or not. So here it's 6.7. Even if it is 6.9, it will lie between 7 and 6.6 only, right? So rank remains same. So if rank is same, so that shows that it will not be, if rank is same, so RS will not change. So here you will just write that rank of France is same, that is 6th, comma, RS remain unchanged. Okay, because data is same, so RS value will be same when you will plug in it to the calculator. Next, Jose concludes from this data that countries with high happiness scores are likely to be favorite expatriate country E. State with reason whether Jose's conclusion is appropriate. So here we need to see the value of RS. So RS value is 0.164 and it is closer to 0, right? So RS is close to 0 and hence Jose's conclusion is not appropriate. That is the reasoning. RS is close to 0 and hence Joe's conclusion is not appropriate. Okay, so that's all for question 1. Hi, let's start question 2 in this video. Sweets are sold in cylindrical container. A new label for the containers is being considered. The label will be a rectangle that is 5 cm wide and 9 cm high. The design on the label is a curve as shown on the following axis, where one unit represents 1 cm for both axes. Okay, so diagram is given to you. Then the value in the table approximate points on the curve correct to one decimal place. Row 1 is for width x, that is 0, 1, 2, 3, 4, 5. Then row 2 height y, 4, 7.3, 6.7, 4, 1.3, 0.7. A. Use the trapezoidal rule with 5 intervals and the values given in the table to estimate the shaded area below the curve. Okay, so trapezoidal rule, let's write down the trapezoidal rule. In that we find out area using the formula h upon 2 y naught plus 2 times y1 plus y2 plus up to yn minus 1 plus yn. Okay, so here h is the width of each interval. H is the width that we find b minus a by n, where n is number of intervals. So they have given that 5 intervals here they have mentioned. So n is 5. What is b? B is the highest value of x, that is 5, minus a is the lowest value of x, that is 0, divided by n is 5. So 5 upon 5, that is 1. So here our width h will be 1, and y naught, y1, y2, yn minus 1, yn, these all are the y values, value of a functions. Okay, so let's see here. According to the given table, our values of y naught, y1, y2, y3 is y naught is when it's the starting value of x, that is 0. At that point y is 4, so y naught will become 4. Y1 is next, because here h is 1, so you will add 1 to the x value to get the next x value. So 0 plus 1 will be 1. For that x, y is 7.3, so we have y1 as 7.3. Y2 will be the next, that is 6.7. Then y3 will be 4.0, y4 will be 1.3, and y5 is 0.7. As we have 5 intervals, so we have 6 values of y, and you will start with y naught, the initial value of x. At that, what is the value of y, and then you will just write all the other values. Okay, now we will apply the formula. So my area is equivalent to h is 1 divided by 2. My y naught is 4 plus 2 times all the values in the middle, that is 7.3, 6.7, 4.0, 1.3 plus the last value, that is 0.7. Okay, now again you will use the calculator to do all the calculations. So that becomes 4 plus 2 times 19.3 plus 0.7. Then that becomes half times 4 plus 38.6 plus 0.7, and that is equal to half times 43.3. So my area is approximately equal to, approximate because we don't write the whole number, we just approximate it up to 3 significant figure. So area will be 21.6 centimeter square, because here 1 unit represent 1 centimeter of for both the axes. Okay, so here we just apply the formula, put the values, and we got the answer. Next, the curve is used in the label design can be modeled by y equal to x cube over 3 minus 3x square plus 6x plus 4 for x between 0 to 5. Use this equation to find the area of the shaded region. So equation they have given, and area under the curve is given to us by the integration. So we will be integrating the given curve from 0 to 5, because x is from 0 to 5, and equation is x cube upon 3 minus 3x square plus 6x plus 4 dx. Okay, so here general power rule of integration will be used, because we have all the x terms with power. So let's do that. X cube integration will be x4 upon 4, and 1 by 3 is a constant that remain as it is, minus 3 again constant remain as it is. Integration of x square will be x cube over 3, then plus 6 again as it is. Integration of x is x square upon 2 plus 4 as it is. Integration of 1 will be x, and we have limit from 0 to 5. So it just become x4 upon 12, 3 and 3 will get cancelled, minus x cube, 2 and you can cancel out 6 by 2, so it becomes 3, 3x square plus 4x, and limits are from 0 to 5. Now you will first substitute the upper limit in the expression and minus the lower limit. Okay, so it becomes 5 to the power 4 upon 12 minus 5 cube plus 3 times 5 square plus 4 times 5 minus, then when you will substitute 0, all the terms will become 0. So I'm just writing 0 for that. Now it becomes 5 to the power 4 is 625 upon 12 minus 125 plus 25 into 3 is 75 plus 20, and that's come out to be 625 upon 12 minus 30, and when you will solve this, your answer will be 625 upon 12, or approximately 22.08 centimeter square. And if you want to write it in three significant figure, it becomes 22.1 centimeter square, because it's 8, so you need to add 1 to the previous one. So this is how we will find the area under the curve using the integration. Okay, so let's move on to the next part. The sweets are sold in closed cylindrical container with radius r and height h. The whole container is made from one type of material, and it is assumed that the thickness of the material is negligible. Each container has a volume of 600 centimeter cube. Write down an equation in terms of r and h that shows this information. So they have given the volume of a cylinder is equal to 600 centimeter cube, and if I see the formula for volume, what is that? Pi r square h. So pi r square h is equal to 600. This is the equation in r and h that shows the information. So that's the answer for part C. Okay, now next is the amount of material used for each container can be modeled by the external surface area of the container. The external surface area A of the container can be expressed as A equal to 2 pi r square plus k upon r, where r is greater than 0 because it's radius, so it will be positive. Then in D they are asking find the value of k. Okay, so here if you see 2 pi r square is same, then it's k upon r, where we are required to find k, and this is area. So if I just write the formula for area of a cylinder, what is that? That is 2 pi r square plus 2 pi rh. This is the area of a cylinder. 2 pi r square is as it is. I will not change anything in that. That I will change here 2 pi rh. Okay, so you can see, let's mark it 1. So from equation 1 you can see r is there, but there is k, there is no h, so we need to replace h. From equation 1, h I can write as 600 from upon r square pi, and put h in 2. Let's write it as 2. So my area become 2 pi r square plus 2 pi r h, that is 600 upon pi r square. Pi and pi get cancelled, 1 r get cancelled, and then it become a equal to 2 pi r square plus 1200 upon r. So from this equation we can write k is 1200. Okay, so that's the value of k. Then next they are saying find dA upon dr, means you need to take the derivative of the area that we got with respect to r. So let's do that. dA upon dr, so 2 pi will be constant, r square derivative is 2r, so ultimately it becomes 2 pi times 2r. Here you need to shift this r to the numerator, so it becomes 1200 r to the power minus 1. Again you will apply power rule, 1200 remain as it is, minus 1 r to the power, you will reduce power by 1, it become minus 2. So your answer is 4 pi r minus 1200 upon r square. Okay, that's the value of dA upon dr. Now next they are saying given that A has a minimum value, find the value of R that will minimize the material used. So basically here we are required to find stationary points, right? Okay, so what we will do in for that, we just put dA upon dr equal to 0 that we got in first part. So 4 pi r minus 1200 upon r square equal to 0. Then you need to take the LCM here. So it become r square 4 pi r cube minus 1200 equal to 0. So ultimately your equation become 4 pi r cube minus 1200 equal to 0. Then if I shift 1200 to other side, so 4 pi r cube equal to 1200 pi, or let's write r cube value. R cube is equal to 1200 upon 4 pi. You can cancel out 1200 by 4. So it becomes 300 upon pi. Now you can just use your calculator to get the value of r. And as r is a radius, we will consider only the positive value. So here I am getting value of r 4.57 centimeter. Okay, so this is the only value that I am getting. And here, so they are saying that given that a has a minimum value, find the value of r. So we have got the value of r that will minimize the material used. So that's the answer for this part. Okay. Okay. So next F part is they are saying if the container are made so that the surface area is minimized. Okay, the 5 centimeter by 9 centimeter rectangular label is to be glued to the curved surface area of the container. Show that the label will fit on the container. So in order to show the label will fit, first of all we will find the height corresponding to this r value. Okay, putting it into the formula of this h. So here my h is equal to 600 upon r square times pi. So it becomes 600 upon my r was 4.57. So 4.57 whole square pi. So this will approximately be equal to 9.14 centimeter. I'm writing in 3 significant figures. Okay. So yeah. And next thing we need to find is the circumference. So circumference of a circle, that is 2 pi r. So that is 2 pi times r 4.57. This will be equal to approximately, again I'm writing in 3 significant figure, and all the values you can find out using your calculator. So now here you can see that 9 is less than 9.14, also 5 is less than 28.7. So that means the longest dimension of the label 9 centimeter is less than both values, hence label will fit. Okay, so the longest dimension of the label 9 centimeter is less than both values, hence label will fit on the container. Okay, okay, so that's it for question 2. Hi, in this video I will discuss question 3. So question 3 is Ayaka is creating a design made from a sequence of rectangles. The diagram shows part of her design using 5 rectangles. So you can see they have given the rectangles. The first rectangle has the following dimensions. Height is 4.5 and width is 3 centimeter. The dimensions of each subsequent rectangles are 2 by 3 of the dimension of the previous rectangle. Okay, so this is important. A, calculate the width of the fifth rectangle. So let's start with part A. They told that dimensions are 2/3 of the previous ones, right? And they're asking us to find the width of the fifth rectangle. So let me write the width of the rectangle. So if I see the width of the first one, that is 3, and the width of second one will be 3 into 2 by 3, because 2/3 of the previous. Then next will be here, if you will cancel, it become 2 into 2 by 3 and so on. So this is 3, 2, 4 by 3. So if you will see the common ratio, then it becomes 2 by 3, and if you will divide again it will be 2 by 3. So this is forming a geometric sequence with R as 2 by 3 and first term is 3, and here they are asking to find the width of fifth rectangle. So width is forming geometric progression, means they are asking us to find the fifth term U5, and formula is UN. Let me write the general formula first. So UN is U1 R to the power n minus 1. So U5 will be U1 R to the power 4. In this case my U1 is 3, R is 2 by 3 to the power 4. Then just use the calculator and you should get the answer as 0.593 centimeter, because the dimension is in centimeter. Okay, this is for part A. Then in part B, they are saying calculate the total width of the design that uses 5 rectangles. Again, they are asking for total width, means we need to find sum, and they are using 5 rectangles here. So we need to find the sum of all the 5 width, that is S5, and in general the formula is U1 1 minus R to the power n upon 1 minus R. We are using that here. U5 means n will be 5. U1 1 minus R to the power 5 upon 1 minus R. So U1 is 3. 1 minus R is 2 by 3. So 2 by 3 to the power 5 upon 1 minus 2 upon 3. So when you will solve it using your calculator, you should get 7.81 centimeter. This is the sum and unit is centimeter. This is the sum of all the 5 width of the rectangles. Okay. Then next they are saying that Ayaka continues to add rectangles to her design. Find the smallest total width that her design cannot exceed. So sum they are asking, right? Total means sum. So maximum width can be S infinity, the maximum sum that we have. And S infinity formula is U1 upon 1 minus R. So we need to find the value of that. That will be the smallest total width that her design cannot exceed. So S infinity in this case will be 3 upon 1 minus 2 upon 3. And when you will solve it, it becomes 3 upon, take the LCM, 3 minus 2 is 1, 1 upon 3. So it becomes 9 centimeter. So the smallest total width that her design cannot exceed is 9 centimeter. Okay, let's see the another part. So the width of Ayaka's final design must be at least 8.5 centimeter and use the least number of rectangles. D. Find the total number of rectangles in her final design. Now they are saying that width of her final design must be at least 8.5. So minimum 8.5, maximum it could be anything, and use the least number. So we need to tell the least number of rectangles, means you need to find n over here. Again using the sum formula, okay, we will just put S of n greater than equal to 8.5. N we are required to find here. So I know Sn is equal to U1 times 1 minus Rn upon 1 minus R. And we have the value of U1R, so we will substitute that. So that is 3, 1 minus 2 by 3 to the power n, because they are talking about width here. So we will take the values accordingly, greater than equal to 8.5. So one way is just you just solve the equation. Another way is you can even draw the curve for both of them, both the sides. Okay, I am just solving it. So 1 minus 2 by 3 to the power n, and this becomes 3 minus 2 upon 3, that is 1 by 3, greater than equal to 8.5. Then this 3 will go up, it becomes 9 times 1 minus 2 by 3 to the power n, greater than equal to 8.5. And then 1 minus 2 by 3 to the power n, greater than equal to 8.5 by 9, and negative 2 by 3 n greater than equal to 8.5 by 9 minus 1. Now I will make it positive. So for that, I will multiply the whole equation by negative sign. In that case, inequality will change. So then it become minus 8.5 by 9 plus 1. You can just plug in this in your calculator. You will get the value and you can solve it. And here I'm getting 8.5 divided by 9 minus, okay, negative. Ultimately here when you will solve, I will be getting n greater than equal to 7.13. So n greater than or equal to, so greater than that least value will be 8. So n will be equal to 8. So you just need to solve the equations, use your calculator or draw the curve, you will be getting the value of n. Okay, then the decreasing area of the rectangles form a geometric sequence. So they already told us that the decreasing area, because the rectangle size is decreasing, so area is also decreasing, form a geometric sequence. Then E, they are asking find the common ratio of the sequence of area. So for that we need to calculate the area. So if I see the first term, let's name it as U1, that will be area of first rectangle. So width is 4.5, sorry, width is 3, height is 4.5. So area will be 4.5 times 3, that is 13.5. I will just find out two consecutive terms because I would require that only to find the ratio, because it's already given that it's a geometric sequence. Okay, then for U2 my width was 2 and height will be 4.5 times 2 by 3, so that will be 3. 3 into 2 will be 6. So for our common ratio it will be U2 upon U1, 6 upon 13.5. So that will come out to be 0.444. It's just going on 444, or you can even write it in fractions, that is 4 by 9. Okay, both ways correct. Okay, so now next is F part. They are saying find the total area of Ayaka's final design. Total area of Ayaka's final design. So here we have first term now, that is 13.5. We have the common ratio. I will be taking this fraction one, that is 4 upon 9, and final design area we need to find. So here, okay, n we got in last, that was 8. We'll be using that. Okay, so we will be finding here S of 8, that is U1 times the same formula I've written here, 1 minus 4 by 9 to the power 8 upon 1 minus 4 by 9. So when you will solve it again, you can just use your calculator. Okay, 1 minus 4 upon 9 to the power 8 upon, take the LCM of 9, so 9 minus 4, that is 5. 5 upon 9, then you can just shift it to upside. So S8 will be 13.5 times 9 upon 5 to 1 minus 4 upon 9. Just directly put it in your calculator and you will get sum as 24.3 centimeter square. Centimeter square, why? Because here we are talking about the area. Okay, so that's all for this question 3. Hi, in this video I'm going to discuss question 4. Gorika is designing a tent in the shape of a right pyramid with a regular hexagonal base, center M. The length of each side of the base is 2 meter. The length of each sloping edge is 3.4 meter, and the distance between each vertex on the base and M is 2 meter as shown in the diagram. You can see this is a 3D view of a tent and another one is 2D view of a base. So top of the tent will be supported by a vertical pole from M, like somewhat like this. M is in the middle. Okay. A, find the length of the pole MT. Okay. So they are asking us to find this MT, and you can see that there is a right angle triangle AMT here. So we will be using that to find the length of MT. So here in triangle AMT, AT square is equal to AM square plus MT square. So AT square minus AM square is MT square, and MT will be square root of AT square minus AM square. It's a length, so it will be positive. So square root of AT square, AT is 3.4 square minus AM, that is 2. So 2 square is MT. So here again you will just plug in the value in your calculator and you will get the answer for MT, that is 2.75 meter in 3 significant figures, and we are getting 2.74954 something in, if I write more significant figures, because in, like I told you, in middle of the calculation we write more significant figures and at the end we approximate up to 3 significant figures. So in order to use this value somewhere else in any other part, I am just writing the value. Okay. Then B part, the hexagonal base can be divided into 6 equilateral triangles. Find the area of the base. So if you see area of the base, there are 6 triangles, so it will be 6 times area of a one equilateral triangle. So you know that each angle in equilateral triangle is 60 degree and each side here is 2. So I will just write half AB sine theta. So half 2 into 2 times sine of 60 degree, because I will write here area of triangle is half, area of non-right angle triangle is half AB sine theta. AB are two sides which is forming the angle theta. So this becomes 6 times 1 by 2 into 2 into 2 into sine 60 is root 3 by 2. 2 and 2 cancel. Then 6 will be cancelled out by 2. So it becomes 6 root 3 meter square. Okay. So do put the units meter square, and approximately that is 10.4 meter square. So both values I have written here, exact as well as approximate up to 3 significant figures. Okay. Then the second part, they are saying the volume of a tent. So volume of the tent is equal to 1/3 times area of base times height. That is the formula we follow. So that is 1 by 3, area of base we got 6 root 3. So I will write exact value in middle of the calculation, times height. Height was empty, so that we found out 2.74954. So this 6 can be cancelled by 3. So it becomes, if you will solve it, then it will comes out to be 9.52 meter cube in 3 significant figures, and otherwise it is something 9.52470. Okay, then let's move on to part C. Find the value of angle MAT. So let's see the angle MAT. This is the angle, right? So here again it's a right angle triangle, so you can use any of the trigonometric ratios. In triangle MAT, I will be using cos. Cos of theta is opposite upon adjacent upon hypotenuse or base upon hypotenuse. So this is AM upon AT. So if you see AM, that is 2 and your AT is 3.4. Theta will be cos inverse 2 upon 3.4, where theta here, let me just write that cos of MAT, then it will be better. So here it becomes cos of MAT So MAT is equal to cos inverse of 2 upon 3.4. Again, you will just put this value in the calculator and find the theta in degrees. So in degrees, it is 54.0 degree and it was 53.9681, somewhat like that. Okay, so that's all for C. Let's move on. For an extra support, Gaurika decides to attach a rope with length 2.6 meter to the tent at a point X on the edge AT. The rope will be fixed to the ground at point Y such that, so this is Y, this is X, this is the rope she attached. The rope XY is straight, point YAB lie on a straight line, and angle AYX is 35 degree. So everything is depicted here in the diagram, both in 3D view and 2D view. This is shown in the diagram. D, find AY. So they are asking you to find the length of AY, this one. So you can see triangle YAX is non-right angle triangle. So then we'll use the formulas for non-right angle triangle. I will be using here sine rule to find the length of AY. So that will be AY upon the opposite angle to AY is sine of YXA equal to, now we have known is 2.6, that is XY upon sine of opposite angle to that will be YAX. Okay, so here we know the value of XY, but these two angles are also unknown to us. We need to find that. So let's find angle YAX first. So angle YAX, we have already found out this angle, right? That we got as 54 approximate and 53.9681 MAT. So your MAT, this was 53.9681 degree. So 180 minus MAT will give you the angle YAX. Okay, so 180 degree minus 53.9681 degree. This will be 126.031 degree. Next, angle YXA. So angle YXA is this angle. So this is the triangle, right? Let me write it here. In triangle, we are considering YAX. So this is the non-right angle triangle. So in this, the sum of all the three angles will be 180 degree. You know this. You know YAX. You know AYX. The third angle you are required to find. So just subtract the other two angles from 180. 180 degree minus 35 degree minus 126.031 degree. So this is 18.9681 degree. So now I will just plug in all the values here. AY upon sine of 18.9681 equal to XY, we know that is 2.6 divided by sine of 126.031. So my AY will be 2.6 times sine of 18.9681 divided by sine of 126.031. Okay, now again you will just plug in all the values in your calculator and you will get the value. So AY will be equal to 1.05 meter in three significant figures. It is 1.04503. Okay. So next thing is, for decoration at night, Gaurika want to fix a strip of light from point A to a point Z along the rope XY. The strip of light AZ is straight and has length 0.9 meter. So along the row XY, so somewhat like this it will be. This will be my Z. Okay, so we need to find YZ. Again, this is a non-right angle triangle.
So we'll be using the formulas for non-right angle triangle. This was also non-right angle triangle earlier, so I used the sine rule. Here we will be using cosine rule. Okay, because I know this side 0.9 meter. I know okay, YZ we are supposed to find. YA also we know already. We know AZ, so only the other side is missing, and angle also we know that is 35 degree. So we can easily find out the length using the cosine rule. So I will be using 0.9 square is equal to YZ square plus 1.04503 square minus 2 into 1.04503 times cos of 35 degree. Okay, now you just need to do the normal calculations. 0.9 square minus 1.04503 square plus 2 into 1.04503 times cos of 35 degree. Put this in your calculator and then directly you will get YZ is equal to 0.185 meter, and another value is 1.53 meter because it's square root, so you will be getting two values here. Okay, because it's a square equation. So these are the two values, possible values of YZ. Okay, so that's all for this question.
Hi, in this video I am going to discuss question 5. So in this question all distances are in kilometers and time is in hours. Let 100 be a displacement of 1 kilometer due east, 010 be a displacement of 1 kilometer due north, and 001 be a vertical displacement of 1 kilometer. Highway 85 in Saudi Arabia is a long straight flat road. Relative to the center of the town, Arar, point O, the position vector of a car C traveling along this road is given by OC vector is equal to 10 minus 50 plus T times 50 minus 330. A, find the speed of the car. So they have given the position vector of the car. So we have a velocity vector 50 minus 330. Magnitude of the velocity vector will give us the speed. So speed of the car will be equal to magnitude of the velocity vector, that is 50 minus 330, that is 50 square plus minus 33 square. You just need to plug in this into your calculator and you will get the answer as 59.9 kilometer per hour. We got in calculator 59.9082. So approximate is 59.9 kilometer per hour. Now, the police are testing a long-range drone D to monitor cars traveling along this road. The drone is launched at t equal to 0 from the point with position vector 20 minus 100.02 and flies in a straight line with a constant height of 0.02 kilometer and a constant velocity of minus 15 minus 20 0. So this is the velocity vector and this is the position vector for the drone. Then B, they are saying find the angle between the path of the car and the path of the drone. So in order to find the angle between two vectors, the angle is same as the angle between their direction vectors. So here we will be using cos theta is equal to B1 dot B2, where B1, B2 are the direction vectors, divide by their magnitude. So I am taking B1 as the direction vector of car, 50 minus 33 and B2, that is direction vector of drone, that is minus 15 minus 20 0. So B1 dot B2, let's do the dot product first. So here we will just be multiplying x component with the of car with x component of drone plus x component of car multiplied by x component y component of drone, means we will be multiplying xx yy zz component and adding. So it becomes 50 into minus 15 plus minus 33 into minus 20 plus 0. So this will ultimately become minus 90. Okay, all the calculations you just need to do in your calculator. Next, cos of theta will be cos theta is equal to minus 90 upon modulus, so that becomes 50 square plus minus 33 square into minus 15 square plus minus 20 square. So cos of theta will be negative 90 upon square root of, okay, let me just write the answer straight away. So that is 59.9082 times 25. So here now theta I am writing in degree. Theta will be cos inverse of minus 90 upon 59.9082 times 25. So your theta value will be 93.4 degrees, because in calculator I am getting the value as 93.4450. Okay. Next, C part is write down the position vector OD vector of the drone at time t. So here they have given us position vector and the velocity vector for the drone. So I will be writing OD vector as the position, that is 200 minus 100 0.02 plus t times the direction vector minus 15 minus 20 0. So this is my position vector OD vector. Okay. Okay, so let's see next one. D part is at time t1 the drone passes through the point with position vector 152 p.02. Find the value of t1 and p. Okay, so here they have given us the position vector, so they have given the position. We will just equate our OD vector to 152 p.02. So it will become 200 minus 100 0.02 plus t times minus 15 minus 20 0, and they have given that at time t1 it has the position vector 152 p 0.02. Now we will be equating them and finding the value of t. So let me just equate the x component. 200 minus 15t equal to 152. So 15t will be equal to 200 minus 152, and your t will come out to be 16 by 5. This is your t value, and in decimal this will be 3.2, and time is in hours. So from here my t1 is 3.2 hours. Okay, now second part, p value. Now you can equate any of them, but in second y component we have p. I will take that equation, that is minus 100 minus 20t equal to p. So basically here we will be considering t1, because we are finding for the given position vector, and that is at time t1. So minus 100 minus 20 times, let me write it in fraction so that we get the exact value. So this become minus 100 minus 4 into 16 equal to p. So in this case I will be getting p as minus 164. So this is the value for p. Then E part. Okay. Find an expression for CD vector, the relative position of the drone from the car. So CD vector will be OD minus OC, final point minus initial. So CD vector will be, my OD was 200 minus 100, 200 minus 100, 0.02 plus t times minus 15 minus 20, 0, minus 15 minus 20, 0, minus the OC vector. OC vector we have, that is given to us here, 10 minus 5, 0. So minus 10 minus 5, 0, and when minus will be multiplied inside, this also become minus, and t will be 50 minus 33, 0. Okay, yeah. Now let's solve it. So 200 minus 10, that will be 190. Okay, then I'm just taking the position vectors and the direction vectors first. So minus 100 minus plus 5, so that will be minus 100 plus, sorry, yeah, this is the minus 100 minus will become plus, so it will become minus 95. Then 0.02 minus 0, so that's just 0.02 plus t times, now let's see the direction vectors, minus 15 minus 50, that is minus 65, minus 20 plus 33, that will be 13, then 0 minus 0, that's just 0. Okay, or we can write it as 190 minus 65t minus 95 plus 13t and 0.02. This is my CD vector. Okay, now let's see the next. They are saying find the shortest distance between the car and the drone. So shortest distance between the car and the drone, we have already got the CD vector, right? So we just need to minimize the distance of this vector. So we will be writing the magnitude of CD vector. This is E second part. This was my first part, and this is E second part. So that will be each component square. So 190 minus 65t whole square plus 13t minus 95 whole square plus 0.02 whole square. So we need to find that t value that minimize this whole expression. So the best way to do this is to draw the graph of this function. Let me show you here in the Desmos. I have already written the equation and I have drawn the graph. So you can see this is the minimum point. Here my x I have written here, that is t time, and the distance will be this 55.893. So this is the lowest value in the graph. So I will get my t as 3.09 hours and CD, the distance that we need to minimize, that we got as 55.893, and that is in kilometers. I think they have given that the distance is in kilometers. Let me just check. Yeah, kilometer. So this will be approximately, if I approximate it to three significant figure, 55.9 kilometer. So that's how you solve the question. So that's all for this. Hi, in this class I'm going to discuss question 6. So Joan is creating animations for a website. He uses matrices to transform objects related to the origin O. One matrix that he uses is A equal to cos 15 minus sin 15, sin 15 cos 15. A, describe fully the transformation represented by matrix A. So if I talk in general, if the matrix is given to us cos theta minus sine theta, cos theta. So this is the rotation anti-clockwise about origin through theta. Okay, this is the standard matrix for anti-clockwise rotation about the origin through angle theta. So if you compare it with A, here I can say that there is anti-clockwise rotation of, here it's 15 degree, so I will write 15 degree about the origin O. Okay, this is the transformation represented by matrix A. Now B. Find the smallest value of n such that an is equal to I, where n belongs to z plus, means positive integers. So here we need to find the smallest value of n such that a to the power n become equal to I, identity matrix. So matrix an represent a rotation of 15 degree, 15 n degree, counterclockwise. Okay, 15 degree anti-clockwise, because A represent the rotation of 15 degree anti-clockwise, so A to the power n will represent a rotation of 15 degree counterclockwise, and here they have given that an should be equal to I. What this means that 15n should be a multiple of 360, right? So in this case, what the condition become, 15n is equal to 360k for some integer k, right? So therefore now n will be equal to 360k upon 15, right? And if you will divide 360 by 15, it become 24k. So now, but what they said, that we need to find smallest value of n. So to find the smallest value of n, we will choose k equal to 1 for smallest value of n. So therefore your n become 24. Okay, so this is the answer for part B. Now next, Juan also uses matrix B, which represents an enlargement with a scale factor of 1.05, center 0, 0. C, first write down matrix B. So in general, if I say an enlargement with a scale factor of K, the transformation matrix is K 0, 0K. Here there is enlargement with scale factor K. So that means what should be our B matrix? 1.050, 0, 1.05, because here the scale factor is 1.05, so K is 1.05. Okay, so this was C part 1. Then part 2, describe fully the transformation represented by B to the power n, where n is the value found in part B. So n is 24. Here they are asking us to find B to the power 24. So you just need to plug in the value of B in your calculator and raise it to power 24. You will get the answer. So that will be 3.230, 3.23. And in case of a diagonal matrix, if you raise the matrix to some power, so you just need to raise the value of the diagonal to that power. Okay, so here we need to also explain. So that means enlargement with a scale factor of 3.23, and that is same as 1.05 to the power 24, and we'll write, because we need to write the center also. So center is origin, so center is 0 comma 0. Okay, so this is the fully transformation represented by B to the power 24. Now next is the part. They are asking, Juan creates a new matrix C. C is equal to AB. Find matrix C. So C is equal to AB. Here we need to do matrix multiplication of A and B. So A is cos 15 degree minus sine 15 degree, sine 15 degree, cos 15 degree, times B, that we got above 1.050, 1.05. Okay, so now when you will multiply these two matrices, you will get first row into first column, so it just become 1.05 cos 15 degree. Then first row into column 2, so it become minus 1.05 sin 15 degree. Then row 2 column 1, 1.05 sin 15 degree. Row 2 column 2, so 1.05 cos 15 degree. So we'll write the exact values for each row. So first of all, I can see 1.05, I can take out common. So then it become cos 15 degree, and I will here cos 15 degree I can't write the exact value for that, but I can just break this 15 degree and apply the formula for that. So I will write cos of 45 degree minus 30 degree, because I know the value of 45 and 30 for both sine and cos. Sine 45 degree minus 30 degree, here again sine 45 degree minus 30 degree, here cos 45 degree minus 30 degree. Now I will just try to write it in proper fractions. So I will remove the decimal. It will become 105 upon 100, and when you will cancel it by 5, so it becomes 21 upon 20. So I'm writing 21 upon 20. Then cos of A minus B is cos A cos B plus sin A sin B, and so it becomes cos A cos B plus sin is opposite in case of cos, sin A sin B. Then sin A minus B is sin A cos B minus cos A sin B. So negative is also outside, so it becomes negative sin A cos B. Negative negative will become plus cos A sin B. Here again sin A cos B minus cos A sin B. Then cos A cos B plus sin A sin B. Fine, now I can just substitute the values. So cos 45 is 1 upon root 2, cos 30 is root 3 by 2, sin 30 is half, and sin 45 is 1 by root 2, again sin 45 1 by root 2, root 3 by 2, 1 by root 2, 1 by 2, 1 by root 2, cos 30 is again root 3 by 2 minus 1 by root 2, 1 by 2, 1 by root 2, root 3 by 2, 1 by root 2, and sin 30 is half. So I can see 2 root 2 is common denominator. I will just take that outside. So it become 21 upon 2 root 2. 20 into 2 will become 40. So it become 40 root 2. And here it's root 3 plus 1 minus root 3 plus 1, root 3 minus 1, root 3 plus 1. Okay, then I can rationalize this. I can just multiply and divide by root 2. So it becomes 21 root 2 upon 80, because 40 into 2 is 80, root 3 plus 1 minus root 3 plus 1, root 3 minus 1, root 3 plus 1. Now I will just multiply root 2 inside, so it becomes 21 upon 80 times root 3 into root 2 is root 6 plus root 2, root 6 minus root 2 minus root 6 plus root 2, and root 6 plus root 2. So this is the product of two matrix A and B. Okay, so yeah, this is the final answer. Next, Juan creates an animation by repeatedly transforming an object by C at a point P on the object is initially at 1, 0. Juan sets the speed of the animation to 6 transformations per second. So speed is 6 transformations per second. Okay, then E sketch the path of P for 4 seconds of motion and label the coordinates of the start and end point. So here your speed they have given 6 transformations per second, and time they have given 4 seconds, right? We need to do it for 4 seconds. So here, and initial they have given 1 0, the coordinate initial at a point P on the object is initially at 1 0. So here if I see total transformations, that will be equal to 6 per seconds time 4 seconds. So that will be equal to 24 transformations. Okay. Then here, as each transformation rotates the point 15 degree and stretches it by a factor of 1.05, right? Because he creates an animation by C, and in C the matrix was 1.05 times cos 15 minus 1.05 sin 15. So here we have rotation of 15 degree and we have a stretch or enlargement by a scale factor of 1.05. So after n transformations the angle will be, so after n transformations angle will be equal to 15 n degree and radius or distance from origin will be 1.05 n. Okay, so the path of P is a spiral. Path of P is a spiral that winds outward. Okay, now here we need to find the initial point and final point. So for start point n equal to 0, so angle is 0 degree and radius is 1 because anything to the power 0 is 1. So your initial point x naught y naught is equal to 1 comma 0. Okay, next we need to find end point. So let's see the conditions for that. So for end, n will be equal to 24. So angle will be equal to 15 degree into 24, that is 360 degree, means full circle will be there, and radius will be equal to 1.05 to the power 24, and that was equivalent to, we already got that, 3.23. So that is 3.23. So coordinates will be, for I am writing for each point starting from x naught y naught and ending at x24 y24, that will be 3.2 cos 360 degree, comma 3.23 3.23 sin 360 degree. Okay, so sin 360 is 0 and cos 360 is 1. So it's just 3.23 comma 0. So this is the start point, end point. So we get all the information about the sketch or the graph. So let's plot that. Okay, so these are the axes, x-axis and y-axis. Okay, so now I will just plot first the initial point, that is 1 comma 0. So let's suppose here it is 1 comma 0 and it will just go like a spiral. We will just plot some dots and it will go somewhere here. It's covering the whole 360 degree angle. Okay, let me just put more space because the value for the end point is 3.23. So if this is 0, so somewhere here will be 3.23 comma 0. So let's make it larger, then only we'll be able to reach up till that point. So somewhat like this, it is a spiral. Okay, so this is the start point. 1 0, and this is the endpoint. Now next they are saying that Joan uses the different transformation t defined by t of xy equal to 0.900 0.8 xy plus 2 1. To create his animation, he repeatedly transforms an object by t. After many transformations, he noticed that all points x, y on the object tend towards a single point pq, such that pq is equal to limit a approaches infinity ta of xy, where a belongs to positive integer. Find pq where pq belongs to real. So let's just paste this question on next page. So we are on this part. Okay. Okay, so now first of all we need to find limit a approaches infinity t of a xy. Then only we will be able to solve this and put this equal to pq, right? Okay, so here txy is equal to, so I can just write it as tx is equal to a x plus b. B is a column matrix, A is some matrix, right? And X is our general vector xy, general column vector xy. Okay, and this is the diagonal matrix you can see. So the eigenvalues will be 0 0.9, 0 0.8 here. Now here for we need to find fixed point PQ. So here they have given limit is equal to PQ. So step 1 will be we need to find TA of X. Let's see what will be that. So if TA of x means you are applying the transformation a times, so it will become a to the power ax plus a to the power a minus 1b plus a to the power a minus 2b plus so on up to ab plus b. Okay, so you see that we can just write it as ta to the power x equal to aax, and if you will see this portion, this is forming a geometric series of matrices. Here you can just take out B common, okay, and write K from 0 to A minus 1 AK. I just write it in summation form, okay, so that we can easily solve it. Now as A approaches infinity, A to the power AX will also approach 0. Why? Because all its eigenvalues are less than 0. Okay? Because all eigenvalues of A are less than 1. So power of A decay. So as you increase the power, its values will decrease. Okay, so now this was the first term. Now second term, B times this is a geometric series of matrices. So here when A approaches infinity, so then A minus 1 will also approach infinity, it will also go closer to infinity. So here K from 0 to infinity, A to the power K, you can even write it as B inside, that is also fine because B is a constant and K is varying, so it will not affect it. So let me write like this, AKB converges like a geometric series. Okay, so here we need to find the limit now. So limit A approaches infinity, TAX will be equal to summation K from 0 to infinity AKB, right? Because first term becomes 0 and rest we have a geometric sequence here. Now here we need to find this value. This is the infinite sum of a geometric series. So if we see the infinite sum n s infinity, its formula is u1 upon 1 minus r. u1 is the first term, r is the common difference. So here if you will see what is your first term, you just substitute k as 0. So if k is 0, so u1 will be b, and common difference will be, you can just take two consecutive terms. So first term is b if I put k0, and second term is AB, third is A square B, and so on. So your common ratio here will be AB by B, that is A. So this term, what it will become? It will become U1, that is B upon 1 minus A. Okay. Yeah, B upon 1 minus A. So this will be equal to B 1 minus A to the power minus 1. This is what we have, limit A approaches infinity TAX. Right? And we know vector B. I have written this equation here. You can compare it. So your B is this. B is equal to column vector 2, 1. A is this matrix 0.90, 0.8. So here we need to find B times this 1 minus A inverse. So let's find I minus A first. So I is 1001, identity matrix, minus A is 0.9, 0, 0, 0.8. So here we are using the concept of geometric series. So I minus A will be just, when you will subtract it, it becomes 0.1, 0, 0, 0.2. This is I minus A. Now we need to find inverse of this matrix. So in order to find inverse, what we do, 1 upon determinant of the matrix, right? That will be the, 0.1 into 0.2 minus 0, right? 0.1 into 0.2 minus 0. So divide by the determinant and we just find the cofactor of this. So that become 0.2, this 0, 0, 0.1. And when you will multiply this 1 upon 0.02 inside, so what it will become? 0.2 upon divided by 0.02. Just a second. Yeah, so this will become equal to 10, 0, 0, 5. So this is my inverse, sorry, not I minus A, that is the inverse we were writing. This is I minus A. So we got the inverse. Now for finding PQ, we just need to do I minus A inverse times B vector. So that means 10, 0, 0, 5 times B vector, that is 2, 1. When you will multiply it, you will get a column vector. So 10 into 2, 20 and 5. So from here P is 20 and Q is 5. So that is the value of P and Q. P is 20 and Q is 5. That's what they ask us to find, and both are real numbers. So that's it for this question. Hi, in this video I'm going to discuss question 7. So the wheel on a motorbike is attached to the frame by a spring. The movement of the spring acts as a shock absorber. When the rider sits on the motorbike, the spring compresses and this position is called the equilibrium position. When the wheel goes into hole or over bumps in the road, the spring will extend or compress to ensure a smooth ride. Let x denotes the vertical displacement in centimeters of the center of the wheel below the equilibrium position as shown in the diagram. So you can see they have given the equilibrium position and they have shown the diagram. This is the vertical displacement. Okay, now the vertical displacement of the center of the wheel at time t seconds can be modeled by the differential equation d2x upon dt square plus a dx upon dt plus bx equal to 0, where a and b are real numbers. Let y equal to dx upon dt. Part A is show that dy upon dt is equal to minus bx minus ay. So we have given d2x upon dt square plus a dx upon dt plus bx equal to 0, and they have given y is equal to dx upon dt. So if y is dx upon dt, then dy upon dt will be equal to d2x upon dt square. You can just plug in this in equation 1. So you will get d2x upon dt square is dy upon dt plus a dx upon dt is y plus bx equal to 0. So shift all the terms to other side and keep dy upon dt on one side minus bx minus ay. So that's what we are required to show. Okay, let's see the next. The equation y equal to dx upon dt and dy by dt is equal to minus bx minus ay can be written in the matrix form as dx upon dt, dy upon dt is equal to m times xy, where m is matrix row 1, 0, 1, row 2 minus b minus a. A manufacturer want to compare two springs, spring 1 and spring 2, that could be used as a shock absorbers. The differential equation for spring 1 has A 18 and B 77. For these values, the eigenvalues of M are minus 7, minus 11. Find the corresponding eigenvectors. So they have given us the eigenvalues and they are asking us to find the corresponding eigenvectors. So we will be using these eigenvalues to find the eigenvectors. We will just substitute it in the equation. We have given the matrix M, that is 0, 1 minus b. So it become minus 77 minus 18. Let's take lambda 1 as minus 7 and lambda 2 as minus 11. They are the two eigenvalues. So now for lambda equal to minus 7, we have m plus 7I times v equal to 0. So let's do m plus 7I will be 7, 1 minus 77 minus 11 times v vector, let it be v1 v2 equal to 0, 0. From here you can form two equations, 7v1 plus v2 equal to 0 and minus 77v1 minus 11v2 equal to 0, right? So from here I can write v2 as minus 7v1. So now I can just write v1 as eigenvectors as, if my v1 is 1, my v2 will be minus 7 according to this condition. So my eigenvector will be 1 minus 7. This is my eigenvector. Let's write it with capital V. Okay. Next, for the another eigenvalue lambda equal to minus 11. Now it become m plus 11v is equal to 0. So m plus 11v will be 11, 1 minus 77 minus 7 times v vector, I will write v1 v2 is equal to 0, 0. Again here we'll get two equations with v1 and v2. So 11 v1, this is v2, sorry, plus v2 equal to 0. So from here I can write v2 as minus 11 v1. So you can use any of the conditions, accordingly you will get the eigenvector. So v2 is, if v1 is 1, v2 will be minus 11. This is eigenvector corresponding to eigenvalue lambda equal to minus 11. Okay, so now next is they are asking us the manufacturer models both springs using the same initial conditions. So they have given the initial conditions, t equal to 0, x equal to 5 and dx upon dt is 2 centimeter per second, x is 5 centimeter. Okay, so hence for spring 1 find exact solution for xt. Okay, so see, first part is we need to find exact solution for xt and this is the initial condition. So let's write the general solution first. So xt yt will be equal to c1 e to the power minus 70 into its eigenvector. Okay, then plus then into, sorry, c2 e to the power minus 11t 1 minus 11 plus, here I missed that. So now we will form two equations, xt is equal to c1 e to the power minus 7t plus c2 e to the power minus 11t, yt is equal to minus 7 c1 e to the power minus 7t minus 11 c2 e to the power minus 11t. Now here they have given us the initial condition that at t equal to 0 x is 5 and dx upon dt is 2. We will be using that. So x of 0 will be c1 plus c2 and that is equal to 5, and y of 0 is equal to minus 7 c1 minus 11 c2, that is equal to 2. Okay. Then we need to solve these two equations, and if you will solve these two equations either by substitution or by elimination, let's just substitute c1 as 5 minus c2 and let me mark it as 1 and 2. From 1 now put in second equation. So minus 7 5 minus c2 minus 11 c2 is equal to 2. So minus 35 plus 7 c2 minus 11 c2 equal to 2. Then it become minus 35 minus so it become plus 7 minus 11. Okay, so that become minus 4 c2 equal to 2. So minus 35 minus 2 is 4 c2. So minus 37 by 4 is c2. Now back substituting value of c2 above, you will get c1. So your c1 is 5 minus c2, so it become plus by 4, 20 plus 37, that is 57 by 4. This is your c1. So finally we got xt as c1 e to the power minus 70 plus, it will be minus because c2 is negative, 37 over 4 e to the power minus 11t. So this is my xt. So they said find the exact solution for xt, then sketch the graph of xt for t between 0 to 1. So it is C, second part, we need to sketch the graph. We have already found out xt. So let's do C part, second. So let's draw the graph of x versus t. Okay. So this is my t, this is my x. So when t is 0, x is 5. Okay, so it will be a decreasing curve starting from 5 and just going closer and closer to this t-axis. Okay, so that means it's decreasing curve starting at 5 and asymptote at x equal to 0. Okay, because you can see it's going closer and closer to this t. So that means its equation is x equal to 0. So and asymptote at x equal to 0. So this is the solution for C, second part. Okay, next. The differential equation for spring 2 has A equal to 18, B equal to 85. For these values, the eigenvalues of M are minus 9 plus minus 2i. D, first part, sketch the phase portrait for spring 2 indicating the direction of the trajectory. Okay, so here we need to just sketch the phase portrait. Okay, A is 18 and B is 85. So in this case your M is, if I write the matrix M 0 1 minus 85 minus 18, and it's given that eigenvalues are minus 9 plus minus 2i. Okay, so here phase portrait, since eigenvalues have negative real part, you can see it's minus 9 and non-zero imaginary part, so the system exhibits a spiral sink. System exhibits a spiral sink. Now the trajectory spiral inward towards the origin. The trajectory is inwards. Okay, it's a spiral that moves inwards towards origin due to damping. Okay, it's inward. Okay, then phase portrait will be finally a spiral moving inward clockwise towards origin, and direction follow the rotation caused by real real negative part and imaginary frequency. So let's see how we'll draw it. This is my y, this is my x, and then we'll start at the point 5, 2. Okay, x is 5, 1, 2, 3, 4, 5, and let's suppose here it will start, and then it will just go on moving inward towards the origin. So somewhat like this it will move. Okay, let me just draw it more accurate. This point will be 2 here, so it start at 2, and also you can show dy upon dt is equal to, if I just substitute x as 5 minus 461, that is less than 0, so that wise we got clockwise spiral here. Okay, so this is clockwise spiral starting at point 5, 2. Okay, next is hence sketch the graph of x against t. So we need to sketch a graph now. So let's see. This was the first part. Now we will solve for the second part. Okay. Again there is a sketch. So let me just plot the x's. Here we have x versus t. So this is my x and this is my t. So it will start at the point 0, 5, and the oscillations will go on decrease. Means the amplitude will go on decrease here. So let me mark, if it is 5 here, it will be somewhat like this, and then amplitude is decreasing here. Okay, so oscillation starts at x equal to 5, and there is decreasing amplitude. Okay, fine. So this was the sketch. Here we have decaying oscillations, and the object vibrates but motion die out over a time. So as per this given eigenvalues, if I write the general solution here, so that will be xt is equal to e to the power minus 90 a cos 2t plus b sin 2t. Right, so we have cos and sin functions, so there will be oscillation b sin 2t. So this is decaying oscillation. The object vibrates, but the motion dies out over time. So you can write this is decaying oscillation, That means the object vibrates, but the motion dies out over time. Okay, fine. So that's all for this part. Next is E. Using your answer to part C second, that is C second that we have done here, that was sketch of xt graph. Okay, and D second, that is sketch of the other one. Give a reason why spring 1 might make a better shock absorber than spring 2. So here if you see spring 1, it's exponential decay and return to equilibrium without oscillation. There is no oscillation, it just comes down, right? If you see the graph here, so it returns to equilibrium without oscillation, so it is fast and smooth, spring 1. And spring 2 have a damped oscillation, takes longer to settle because there are oscillations, so it takes longer to settle, may cause multiple rebounds. So spring 1 is better shock observer because it returns to equilibrium faster and without oscillations. Okay, so spring 2 will take time to be stable. So for this is our E part. You can write E. Spring 1 is better okay shock absorber because it returns to equilibrium faster and without oscillation, reducing vibrations and wear. So there will be lesser vibrations because there is no oscillations here, right? And wear. So spring 1 is better. So that's all for this question.